Okay. Let's get back to, oops, clear this and start over. Tried this once, didn't really go too well. So round two. So we have the third operation that we're going to look at with complex numbers that are in polar form, and that is taking a complex number and raising it to an exponent. So we've talked about multiplication, we've talked about division. This is a very specialized theorem. It's a French name. I'm not exactly sure how to pronounce it, but I'm going to say it's DeMoivre's theorem. Okay, DeMoivre's theorem. So this is a very, like I said, very specialized for how we can shortcut this process for raising a complex number in polar form to a power. So if I have any complex number written like this in polar form, if I want to raise that number to an exponent, then I would essentially be taking this entire, isn't that working? Taking this entire format and raising it to the nth power. Okay, and the shortcut for doing so is to take the modulus and raise it to that power, but then take that number n out of the exponential level and multiply it times the argument, or multiply it times theta. So we use it as an exponent once here, and we use it as a part of a product in here with theta. So let's model this one time. Suppose I have a complex number that has a modulus of 3 and an argument of 120, and I want to raise that complex number to the third power. So that would essentially be taking this entire piece, this entire number, and raising it to the fourth power. According to DeMoivre's theorem, I take 3 and I raise it to the fourth power here. And then I'm going to bring brackets in because I've got operations happening in here where I'm taking the cosine of 4 times 120 plus I times the sine of 4 times 120. Now, it's not as simple as just taking this and calculating it. That is obviously a part of it. 3 to the fourth power is 81. And then in here, I'll have the cosine of 480 plus I times the sine of 480. Now, just like in a previous problem, we don't want to keep our angles greater than 360, right? We're going to find the coterminal angle for this that is between 0 and 360. If this was in radians, we'd want the coterminal angle between 0 and 2 pi. So coterminal angles, we subtract 360 from that. So our final answer would be 81. And I'm using a bracket, this could easily be a parenthesis, and that would be fine, times the cosine of 120 plus I times the sine of 120. This would be the polar form of that number. And because this problem starts in polar form, we probably want to end our answer in polar form. But just for the sake of, keeping the content moving, I could write this in standard form if I leave the 81 on the outside briefly and then calculate the real number value for the cosine of 120. The cosine of 120 is the x coordinate at 120, which is -1/2. And the sine value at 120 is radical 3 over 2. And then I would multiply 81 times both of these, -81 over 2 plus 81 radical 3 over 2 with an I, right? When I multiply a integer like this or a whole number like this times a fraction, I only multiply it times the top. So that's why I have the 81 here and here. I can put a box around this. Just a reminder, this is standard form, right? And up here we have polar form.